Hi, so I made a video on similar triangles and the intro for that wasn't that great. So I'm just re-recording it here and I'm gonna edit this into the beginning. I hope you enjoy it and I hope it's helpful for that. So now I'm gonna show you a possible application of this or just examples of something entirely new. Similar figures and proportions. Let's look here. Right here we have a similar figure. These are two similar figures. Triangles. You have a smaller triangle and a larger triangle. Smaller within the larger. And take note, this line is not the same as this line in terms of visual representation. But that's irrelevant because we can see that these angles, representing that they're congruent, are the same. Meaning that we can prove it's similar by angle or AA, because this angle has to be the same once these angles are, because all angles inside of a triangle equal 180. So technically, angle. Now let's see how we might be able to possibly, apply this into a question. How about A, C, B, and D? That's what all of these sides are worth. That's what I'm giving them. We can put A over C equals, and then you put the other triangle's proportions, AD, which is this entire side, A plus B over D. That's how you go about solving it. Assuming these were numbers, you might be able to mix them, and you'd have to solve for the value of x. So that's about it for similar triangles and proportions. Now I'm going to come back with a different example of solving for x. It might be a little bit more complicated, but so if you don't want to watch that, that's okay. This should be good enough. But that's just going to go a little bit more into depth on this concept. Hi there. So I'm back with that equation that I mentioned. Not equation, problem. We're going to be dealing with areas and outer values. So let's take a look here. You have an example of 12 squared and 14 squared, which is the area, or yeah. So let's write those down. 12 over 14. And now to make sure that we keep these consistent, we're going to want to put the 4 from here over the x. We have to make sure that the values remain correct, so that we can get the correct answer. That's going to be 4 over x. However, we need to square these numbers. Because these numbers are already squared, we're going to need to get these to be the same value as that. Because if this is centimeters, and this is centimeters squared, then you can't use terms that aren't alike. So let's go ahead and do that. 12 over 14 equals 16 over x squared. And we're going to have to cross multiply here. However, these are pretty big numbers, so we're going to have to simplify. Or we should simplify, just to facilitate this. Now, 16 and 12 are both divisible by 4. And since they're not multiplying against each other, we're allowed to simplify them. So let's go ahead and do that. 4 and 3 is what we're left with once we divide by 4. So now we can multiply with relative ease. 3x squared equals 14 times 4, 28. No. 14 times 4 would be 28. 30. It's 36, guys. No, it's not. 14 times 4, 46. That's what it is. Sorry. Small calculational error. I was thinking about it wrong. Anyways, 14 times 4 is 56. My mistake, again. Because we already have a 40 with the 4, and then we can multiply 4 by 4, making a 16. Now, let's see. Is this divisible by 3? One neat trick is adding these two numbers, 5 plus 6, and seeing if it's something divisible by 3. In this case, 11? No. So we're going to have to move 3 and divide it anyways. However, we can just leave it as a fraction to simplify things for us, or over 3. However, we still have x squared, and not the actual value of x. So we're going to want to square root this. X equals root 56 over 8, which can be simplified. Got you there. 56 over 8 is actually just 7. So x equals root 7. And that's an example of an equation. This was unnecessary, just something I thought might be helpful. I hope the video helps you prepare for finals and that things go well. Thank you for watching. Yeah.